Hello, Mr. Minnick here, helping my students begin the Maze 1 project in our Intro to Computer Science Python class. Here are the specs for 2017-18. Please review them carefully. Your first step is to obtain a piece of grid paper and create a maze that contains 5 or more inner, vertical, and or horizontal walls. I'm going to do that and resume this video after I've completed 5 inner walls of the maze. Okay, so here you go. Here is my maze that fulfills the minimal requirements, which are enough for an A if I do everything else correctly here in 2017-18. Notice that to get full credit here, I do have enough walls. I'm going to count them with you. 1, 2, and then this whole wall right here is a third wall. That does not count as 2 walls just because of this dot. It's 1 horizontal wall. It's 3 total. Here's a 4th wall, vertical wall, and a 5th wall. Now the start of my maze I expect to be up here in the upper left corner, and the player will come around here, come down here, and go through this hallway, and the finish line will be like around this corner down here tucked in the lower left corner. Maybe I want to put an F there for finish and an S here for start. Notice there are no dead zones where that are filled in where the player cannot reach. I want a nice big open hallway kind of maze that uses up the whole 400 by 400 grid. Okay, notice also that all the endpoints of my line segments end on like nice little intersections of the grid lines. I very carefully, as neat as I could, perhaps using Notability on my school-issued iPad, I made little dots here at the little points of intersection. I also, to get full credit on this assignment during the design stage of the programming process, I'm labeling all the endpoints with XY coordinates of these line segments. -200, 130, 120, 130. Oh, that's a mistake. Whoops. That would have caused a diagonal line there. I think that should be 120 there. Yes, 100, 110, 120 matches up that spot. Oh no, the 120 was correct. The second number is the Y coordinate, which matches up with this 130 here. That's 100. This is positive 110, 120, 130. So that really was indeed a 130. So please double check the rest of these points. This point matches that coordinate, this matches this one, etc. Also, according to the recommended way of finishing this project, all horizontal lines should be numbered H1 through H whatever, starting from the top, methodically moving down. So this line is labeled H1 somewhere in the middle of the line segment. This line here is H2. This whole line here is H3. And then vertical lines should then be numbered from 1 to whatever using the notation V1, V2, V3, etc. from left to right. So this line segment is V1 and this other vertical line segment is V2. With good organization during the design phase of the programming process, your coding and debugging during the 3rd and 4th steps is much easier. Okay, so now what do we do as our next step in this assignment? Well, the next step recommends that you go online and find my template, the starter version of this assignment. I recommend that you just copy and paste all the code that you see here in my Google Doc called Maze Demo 1, and I recommend that you highlight it all or use the menu command Edit Select All here and highlight it all and then do a Edit Copy and go over into your trinket area and start a blank project. I don't recommend that you try to remix the online version that you might find in my website. I recommend that you just go to my new trinket and a regular old Python trinket like we're used to doing here, and paste the code that you just got from my starter project right here like so. Rename it to whatever the project is supposed to be named. I don't like to put spaces in the names of projects usually. And let's save this just to be careful and not lose it. And change your name, of course, to your real name, perhaps Jane Doe or Jane Smith, depending on whether you want your last name on the code or not. Now, do not mess with the code that I've provided to you. Perhaps I haven't taught you how functions, DEF, stands for a defined function. See how you can like shrink that up? Do not delete things that you don't understand. Currently, if you run the project after a copy and pasting like that, you can move the lonely turtle around using the arrow keys on the keyboard. Now, anytime you hit a boundary, it resets. All four boundaries hitting the four boundaries cause the turtle to reset to the middle. If the middle of the grid is not your starting point, then you will have to come in here to these nice best practice use constants and change the starting point to whatever location you would need to start at. For example, in my grid, the starting point for the turtle is approximately -180 and positive 180. Perhaps right there would be the top left corner of my turtle. That's the point, -180, positive 180. So by editing my code, these two constants to -180 and positive 180, that simple change, and then lining up these hashtags nicely, watch what happens now when I hit a wall of the maze. It resets to that top left corner, and that now is my new starting position in this version of my program. If you want the player to move more with each press of the arrow key, then make this a larger number. If you want the turtle to move real slowly with a move amount of only 1, as if it were like a baby turtle crawling, well then use the number 1 there, and now it moves really, really slow when I hold down the arrow keys. I'm going to change that back to 10 as my move amount, and these constants are used in the correct spots of the code. There's move amount, and there is start position X and start position Y. You could always put the 10 here and here and many other places, but this is very convenient at the top of your code to have constants that are then used further down in the code for the ease of upgrading the program. Okay, moving on with changes that you'll need to make to get a good grade on this project. You should not have to change anything in the setting up the screen area. You should not change anything in these functions, the function called draw maze. Since you're using the same boundaries that I'm using, you should not change that. But yes, you should come into the draw maze function where everything is indented because of Python's rules. And you will have to add code here in this little to-do reminder area. You'll need to add code that draws each horizontal line. So let's start with that aspect of the program. Now, one of my walls, my first wall, H1, goes from -200, 130 to the point 120, 130. So let's put those coordinates in where they need to be. I'm going to copy and paste this sample code here. I'm going to copy that and put it right down here. and keeping that sample there, but taking away the green hashtag comment markers. And since this is really my H1, this is, I'll just say line H1 here. And I believe it went from the point negative 200, 130, negative 200, comma 130. And with the pen up and then putting the pen down so that you can then move to the second end point of the line segment, 120, 130, 120, 130, I have to remember. By putting those two numbers in there, watch what happens when I incrementally test my program with just H1 being drawn with those lines of code. Now I do indeed have my first horizontal line that matches nicely with this top horizontal line that extends across the top of the grid. Now that I'm happy with that line, oh, notice right now if we were to like run into that line, it does not reset the player like eventually it will if you want a good grade. That's because we haven't added the if statements yet that do what's called collision detection. But right now I'm going to just finish copying and pasting either this sample code that I gave you in my starter file or this code that I've now tested for H1. And I'm going to go ahead and implement what I call H2, which is this line right here that goes from this point to this point. I'm going to pause the video and rejoin you in a microsecond with those coordinates typed in. Here I am back with this code updated so that those four numbers match the endpoints of this horizontal line segment that I labeled H2. Let's test it and run this trinket project to see if it works. And it does. The two lines do now make for the top of the maze area where the turtle can come around here, come down here, and proceed with the rest of the maze. I'll leave it to you as an exercise, of course, to make your H1 and H2 match your project. And I do need to make sure my indentation is lined up nicely there. So it looks like you have more work to do in this section of the code. Let's look at the vertical lines. Now here's a sample. I'm going to copy and paste. And we're going to turn this into my vertical line. Let's see here. I have, how many hashtags do I have? I'm going to make sure that my code is really super consistent. And that's going to be my section for my vertical line 1. Now vertical lines, instead of vertical lines having the same second parameter like the horizontal lines have, vertical lines, the X is always the same with a vertical line segment, not the Y coordinates. Anyway, over here in my grid, my vertical 1 line goes from negative 120, 50 to negative 120, negative 30. So by updating my code accordingly, this first, sorry about that, this first coordinate, taking away the hashtags, of course, so that we can make this code live and actually work. The first was negative 120, and now I forgot the number. It was positive 50. So by putting a positive 50 there, and then getting the point negative 120, negative 30, negative 120, negative 30. If I run my trinket now, I should see the nice vertical line here that matches the vertical line that you see right here. So far so good. I have one more vertical line to do, and I have one more horizontal line to do for my lines to be fully drawn. So I'm going to now move forward with the next part of this project, which for you folks, perhaps you want to shrink up, retract the draw maze function so it doesn't clutter up your code window. And now you'll be moving down here into these, past these other functions that I don't want you to mess with. Otherwise, you won't be able to move your turtle around very nicely. We're moving down to the section for check collision. In the check collision area, you have some to-do work to do. So now we have some to-do work to do down here in the if statements. So for collision detection to work, you need to copy and paste this sample if statement, paste a copy of it below, and for each horizontal line that you have, you'll need an if statement that is not commented out like that one is. Now here's the magic that will make it work. See the numbers 120, negative 120, and 40? Well, let's go look at our horizontal line 1. The horizontal line 1 has a y endpoint of 130 here and, of course, 130 here. So the y endpoint would need to be the number that is both here and here. No, I'm sorry. That was the opposite of what you want. The y endpoint needs to be right here. No, I'm sorry. The y coordinate, y core. That 130 would need to be there. Now this x core here where you have greater than has to be the left end of your horizontal line 1. The left end is at negative 200. So that would need to be a negative 200 for my line to work. And this number over here would have to be where it's x coordinate less than, not to be confused with this x coordinate greater than. This would need to be the right endpoint of your horizontal line segment and the x number, 120. So the 120 would need to go right here. If I updated these three numbers correctly, watch what happens when I run my trinket now. Horizontal line 1 is H1 right here, and if I move my mouse, my turtle, around the edge, it works fine. It does not reset. But if I slam against that line coming from the top, it does reset back to the beginning. If I come around the bottom with that if statement working correctly and slam into it from the bottom, it does reset. And one more test, if I slam it from, say, the end, like putting something on a shish kebab, see that? Watch. It does reset. So that line does work correctly because of this if statement. Read my lecture notes or watch any other videos if you want to really, truly understand why the greater than negative 200 works there and the less than or equal to 120 works there and the double equals 130 works there with the y and then the x and the x. But at this point you would copy and paste this and you would do all this again for line 2, H2 rather. That was just a sample up there. And of course these numbers would need to be changed to match the numbers on H2. Well, I'll just do it for you. The y coordinate is 50 and 50 there. So that means that the y core, where you see y core, that would need to be a 50. And the left endpoint of my second horizontal line segment is negative 120. So this left endpoint here needs to be negative 120. And the right endpoint, I believe, is positive 200. So this point over here would need to be positive 200. I'll test it later. You should test it as you go. I'm going to test it to make the video a little shorter. I'm going to come down and do a vertical line, and then this video will be finished. By copying and pasting this sample right here, copy, and then coming down here, paste. Oh, by the way, I always like blank lines between separate if statements. That's just good style. And don't forget that the return true must be indented further in than the word if. Real quickly, a vertical line, for vertical lines to work, the x coordinate for a vertical line, like right here, the x coordinate is negative 120 here and negative 120 here. So in my sample, The x-coordinate here would, oh, what a coincidence. It needs to be stay 120 like my sample was. And now we have a top endpoint and a bottom endpoint. This one that is actually the top endpoint, and this one's the bottom for the y endpoints. So over here, my vertical line has a top endpoint of y equals 50 and a bottom endpoint of y equals negative 30. 50 and negative 30. So 50 is the top endpoint that would go here, and a negative 30 goes right here. If this works, I'm testing it, and let's do a runtime test of this. All three lines that are drawn should now work as far as me colliding with them. Let's hit this one right here, horizontal line, bam, it works. Let's come around here and now hit my vertical line. Let's hit it from the left, and bam, it works. It reset me to the top left corner. Now that isn't a thorough enough test. We need to come around here and test the vertical line, say, coming from the right. And it works. And one more good test or two. Very thoroughly, patiently testing each line as we go. Let's test this horizontal line from the bottom. Bam, it works. And we should also, like the shish kebab idea, we should test the horizontal line, but shish kebabbing this marshmallow on a marshmallow stick, say, right there. And one more good test. Let's hit the vertical line from the bottom. That would be a good test. Let's get a running start here. Bam, 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 and boom. It does reset. And I guess we should also hit the vertical line from the top, and it does work. Now, it's not really necessary to come out of play here and test this horizontal line coming from the left. It's not really necessary to somehow cheat and come off the boundary and test this horizontal line from the right. But because our boundaries currently work, so that's that. Okay, good luck. There are some optional upgrades for go-getters in the specs for this assignment. Good luck if you want to try to do things like these bullets here. Like you could make portals that let you magically go from one area to another. You could maybe have an exit like in the Pac-Man game from the 1980s where you can go off one side and come in the other. In that case, you'd have to sort of make a hole in your boundary here and here so that the turtle can go off one side of the maze and come in the other. But those would be things that go-getters would have to do for more credit. Okay, I'm going to save this and continue working on it on another day. Please, please do not mess with or break another area of this demo program that was given to you. You're really just coming into these to-do areas, and you're updating the if statements here in this section. And just to review, up in the draw maze function, you are adding some areas like this, pen up, go to, pen down, to draw the rest of your maze. Have a great day.